my name's Dan Korhnak. I work for Matrix Solutions. I run the software team down there.
Yep, I'm Nick Treu. I'm a developer on the software team at Matrix Solutions.
Okay, so today we're going to talk about Azure Functions, and we're sneaking in some stuff about our love of F# also, which is a functional programming language, right? But they tie together, so it's cool, right? Okay, so what we're going to do today, we're going to just do a quick Matrix overview. We'll talk about our technology and the evolution of our technology, just to give you a little sense of what we're going through in the world. We'll talk through serverless architecture and Azure Functions. Azure Functions being the implementation of a serverless architecture, and then F# versus C# in this context. So first, this thing double clicks all the time, so it's really hard. Little overview on Matrix. So Matrix Solutions, we're a company over on the north side. We build a global media ad sales platform called Monarch. And what that means is if you're a media company and you're looking to sell advertising, we can help you do that. So we work with companies large and small, all different sorts of media companies. So if you know someone looking for an ad sales platform, we're the people. Plus the tech is pretty cool. So quick overview on our tech. A lot of it is kind of traditional, and then we do some pretty interesting stuff on top of that, right? So traditional stuff being AngularJS, that's traditional now, right? So we got thin client AngularJS built on top of a backend that's mostly ASP.NET Web API, okay? It's been around for a while. It was C# mostly. We've been working in some F# over the past couple years. For various reasons, which I'll go into in a second. SQL Server backend, a lot of relational data, and we've been getting into Microsoft Azure a lot over the past couple of years. So Azure being the cloud offering from Microsoft. So F# we've been getting into because it kind of fits our model well. It's all about data transformations. It's a functional paradigm. We deal a lot with just data, transforming data, a lot of stateless stuff, and so that helps with that a lot. C# is a great language also. I know it's a lot of times people like Python, JavaScript, things like that. C# really come a long ways, and .NET, especially .NET Core, which you'll see a little bit of today, has been working out pretty well over the past, I guess the past year it's really matured. So Azure, we do a lot of stuff in Azure. I mean, Azure's obviously a huge cloud offering. We do app services, Azure Functions, storage, tables, blobs, queues, and Event Hub, which is like a streaming data thing that we use to glue a lot of our stuff together. Okay. If it clicks. My clicker's not working, so. All right. So the evolution of Matrix. So remember how I said it's like an ASP.NET SQL Server application. So, traditionally our application in the past, it was a monolithic application. Have you guys ever heard of like a monolith application, right? So basically what that means is it's a single application that serves many functions, kind of a single code base, lots of shared resources. And it's good when you're starting out because it's simple to operate, it's simple to deploy, it's easy to get your head around. So a lot of times when you're starting out, that's the way to go, and it makes it easy. But the ceiling of what you can squeeze out of that application is limited. It makes it harder to kind of change things as the complexity grows. You touch one thing over here, you break another thing over there, and it becomes really hard to maintain. And maintainability, especially in my role, maintainability is a huge thing. We could write something today, build out a feature, but if 2 years from now, if I can't continue to build a business on that, it's a big problem for me, right? So you got to take the long view on things. The more functions a single application serves, the more complex it becomes, and you really need to start thinking about breaking it up and deconstructing it into smaller parts. Okay. I forget that doesn't work. Okay, so how do you break it up, right? And it's not easy. It's really hard, actually. The reason is like as this application was built, all these different features kind of get coupled together and they get built on, and they get kind of these hidden dependencies on each other that are hard to detect, and it's real easy to break things, as I was saying. And you are running business, you have to continue to deliver business value. You can't just like stop and be like, I'm going to rewrite this thing for the next year. Okay, so the approach that we take is like, as we build new things, if we decide as a business we're going to build cool widget X, we're going to look to take that opportunity to kind of peel off some functionality for touching something and enhancing it. We break it up then into a new component and go from there, right? So as we add that capability, it's very important to us that we're really committed to breaking it out to a different component and not coupling it to the existing platform, okay? So we still have our monolith, but we're kind of starting to break some pieces off because it gives us a lot of flexibility, okay? So one of the ways we're doing that is doing serverless, taking a serverless approach with Azure Functions, okay? Azure Functions is just a choice for us, right? You can do it many different ways, but this is kind of the why for us, why we're using Azure Functions. Another term for serverless that you might see is function as a service, because we all know serverless doesn't really mean serverless. There's servers somewhere, right? But it's function as a service, okay? So you may see that term out there. I don't know, has anyone ever heard function as a service before? No, okay. It's definitely not as popular or buzzy as serverless, that's for sure. Okay, so then the question is, what is serverless? And I think to answer that, you first got to think, what is a function? A function is a single block of code that yields an output in response to an input and has no side effects. Okay, and it sounds really basic, but it's actually really important, right? There's an input, you get an output, nothing else changes in between. There's no side effects. It's completely stateless, okay? That's kind of my definition. I'm sure I stole it from somewhere, but that's the basic idea. Okay, so expanding on that, once you understand what a function is, serverless means that you've got functions that are fully managed. It all runs on a fully managed infrastructure. You have an execution framework for the code. So those functions, there's some framework around it. There's some guide rails. You can only do so much. There's guidance and there's patterns and things like that. It's stateless, right? So no side effects, doesn't hold anything in memory except for during the lifetime of the execution. One execution of that function is not dependent on any other execution, et cetera, et cetera. It's reactive to external events. Basically, something happens outside the function, that can kick off the execution. The execution is short-lived, and all these things together kind of make it horizontally scalable, right? Well, not fully managed infrastructure, although that helps, right? But the fact that it's stateless, short-lived, all those things mean you can run many instances of these in parallel and not impact each other, as long as you have the machines to scale out to. Okay. So I guess a little more why, right? Scaling, which I just touched on. Flexibility, right? So using a platform like Azure, there's a lot of capability there. There's more capability than we could build in our team. We're a pretty small team, 30-person company. We can come up with event hubs and Cosmos DB and all these things. And this gives us a lot of options, a lot of flexibility. Reducing the infrastructure code that we have to write. In the past, years ago, there's a lot of code you end up writing to kind of wire things together, and you get good ideas, incorporating things in your monolithic application. You do stuff that you really doesn't deliver direct business value, it just supports your application. Taking a serverless approach takes a lot of that away. It's quick to develop and deploy. You can get up and running in under 5 minutes, right? It's very quick, and it's consumption pricing, right? So if I put a function out there and it never gets used, I don't pay for it. If it gets used a million times, then maybe I have to pay, but it's probably a good problem. Okay. Any questions so far? Any questions on any of this? Yeah.
So you said whenever you were first starting out, you started with that kind of monolithic, this monolith. Is there a way to start out in a way that's more conducive to like not having that that monolith, but it's still like effective and like usable to start out?
Yeah, it depends, which is not a great answer, but a lot of times you can, if you try to get too decoupled up front, depending on your use cases, you can kind of get yourself in trouble because you're kind of like building complexity and it doesn't need to happen first. Monolith, the advantage is it's simple, easy to get your head around, so you can get off the ground pretty quick that way too and quickly add features on. If you know what you're doing, you know exactly kind of like the problems you're trying to solve, absolutely functions. Or if it's a very targeted problem, like it's easy to start that way. I think kind of as this world matures, because Azure Functions, I think we've started using them not quite 2 years ago. We just as they went GAs when we started using them, and it's still kind of a new approach. And I think over time it's going to mature, more patterns will show up, and then it might be a little easier. The way we think about it today, if we build something new, we do try to think functions first, but of course it's integrating with our platform. So, does that help?
Yeah.
Okay. Okay, so here's the different providers. Azure Functions, that's Microsoft. AWS Lambda. I should mention Azure Functions today in version 2.0 supports .NET, so C#, F#, and JavaScript. Python's coming soon, I believe, because their 1X version supported Python as well. I think AWS Lambda, Python, JavaScript, .NET Core, Google Cloud Functions I'm not as familiar with. I imagine the same, really. Java. Yeah, I think Lambda supports Java also. 1X version of Functions supported Java. I think the 2X will eventually as well. Okay, so then, what actually, getting a little more concrete then, what does a function do? So all these things on the left, these are triggers. All these things on the right are bindings. In the middle is code, okay? So what a trigger is, a trigger kicks off a function, okay? So if you get an HTTP call in, or a file gets uploaded to blob storage or something like that, that will trigger the function, okay? That's kind of built into the platform. You don't have to worry about it. You can count on it actually like just working. It just works. Very rarely do we have a problem with it. You can do timers, things like that, okay? So when that function triggers, then your code's gonna execute. You're gonna use the little magic lightning bolt there and execute our code, and the output of the function then goes to a binding, okay? So literally in your code, you define the binding and you would say, okay, when this thing executes, write it to Azure Cosmos DB. You don't need to know much about Cosmos DB except your connection string and all of that. If you decide Cosmos DB doesn't make sense anymore, you can literally just change a couple things and you're writing the blob instead. So your core business logic stays the same, and you just change your bindings and triggers depending on the sort of resources, persistent state that you want to use. And that's really, really convenient because it makes it so you can try things quickly, you can adjust quickly, you can kind of just take these things and plug them into each other and go, right? You can have one function write to a blob, and then another function triggers off that blob, and you start chaining things together. So you can make things really componentized. So this is just like a basic example. So if a request is made into a web app, that web app can queue it on a service bus. Okay, it allows everything just kind of queue up. Function fires off that service bus, processes it, maybe writes the output to Cosmos DB, right? So this is like kind of how we think about our functions. It's like, what's the trigger going to be? What's the output going to be? What goes in the middle? There's a bunch of options. They can do things now. I haven't tried it yet, but they can do things like Office 365 Excel row updates. You can trigger an Azure function. Blobs. You can send SMS, emails out the back end. You can do some really cool things really quickly. So it's pretty nice. And then just kind of the environment before we get into the code here. It's fully platform at this point. .NET Core, they've worked a lot. Like Microsoft spend all cross-platform everything. They're really trying to embrace the developer, and so they've caught up to some of the other like lower friction languages with .NET Core. Azure Functions Core tool also fully cross-platform, and these are sort of CLI things that are going to help us build things and bootstrap things quickly. And then Visual Studio Code is cross-platform text editor, multi-language, that sort of thing. So this is kind of like the go-to environment for getting up and off the ground with Azure Functions. So Nick is going to come on down and kind of start taking us through some code.
The team down at Matrix. I went to Pitt back in the day, a couple years ago. Yeah, not very long ago actually, just 2 years ago. I graduated in 2016, but it's good to be back and get back to the guys here. But anyway, tonight we're really going to go into depth in this code about Azure Functions. We're going to look at a C# implementation of a function that's triggered on an HTTP call. That's one of the triggers that Dan mentioned earlier. Then we're going to talk about very, very high level about functional programming. And just for, by show of hands, anyone never used a functional programming language before, like F# or Haskell? Yeah? No, oh, never? Okay. Yeah, so we'll go through some of that, very high level. We'll keep it really simple. And then we're going to go through an implementation of the same function, but in F#. And hopefully, we'll compare and contrast the two. You'll see the differences, and hopefully by the end, you'll see why we prefer to do these things in F#. So, what is this function going to do, right? Like when we make an HTTP call, what's going to happen? So it's just going to be really simple. We're just going to put a post up there. We're going to just copy the JSON body from it. And from the JSON blob, we're going to say if there's a name and an age property, we're just going to respond with what the name and the age property is in a message. And like the other cases of if it has just the name in the JSON, we'll say, hey, we got a name, we didn't get an age. We'll say if we just get the age, we don't have the name, we just have the age. And if we get neither, we'll say hey, you didn't give us either. Does that make sense? Really simple? Cool. So let's dive into some code here in C#. And actually, before I do that, I'm going to really quickly show how simple it is to make one of these functions. So I just made a directory, really simple, and we're going to actually use the Azure tool CLI to make an HTTP function. So I have installed already. So all I have to do is say func-init, and it gives me the option of what runtime language I want. So I can either make a function in .NET, Node, or Python. I'm going to choose .NET. And this will initialize this directory as being a function directory. So then I can say func new, and I can choose here what sort of function I want. So there's a few options here. It can be triggered on a queue, HTTP trigger, which is what we're going to look at tonight. And there's a couple other options here, but for this example, we're just going to choose an HTTP trigger. We'll give it a name. We'll call it func example or something like that. And it's going to go off and make this function. It succeeded. And let's just look really quickly. Sorry about this. At what a new function looks like. So we just go to this folder in Visual Studio Code. We can see, hey, it made a bunch of files for me, and it gave me a scaffold of very simple function, and from here I can build on it. But before we came, I already implemented this. I'm just going to walk through the code of it. So, can you guys see this, by the way? You guys see that? Awesome. Okay. So, a couple things I want to touch on right here off the bat is we have this function name. Using function CLI, you can have multiple functions in the same project. So this is just saying this is what my function is going to be named, and we get a run body. So since this is an HTTP trigger function, the input of this function is going to be this .NET HTTP request message, which has the body and some header stuff on it. And it's going to return the HTTP response message. I'm sure you guys are familiar with this kind of syntax. And we get a logger too, so we can log information if we want to. And looking at this code here, just the main body of the function so we can see what it does. We're going to take the request, get the content, we're going to read the string and get the result. That's just basically saying like, here's my body, I'm going to parse that JSON as a string, just read it in. Then, we're going to get like the deserialized object and make it like an actual object in C#. So this is like this args object, which just looks like this. It has our name and our string, and this JSON convert will do that for us. Then we have like a validator object I wrote, which validates, and then from that validation we can make a response message. Make sense so far? Cool.
Hey, one thing, can you
Yes.
explain like the attributes and stuff like that just a little bit more? Because I think the runtime looks at those to actually know what to do with this code when we upload it, right?
You mean like the trigger?
Yeah.
Sure, yeah. I mean, you can have different triggers here, like what you said. Like it can be triggered on a queue. If something's like enqueued into a queue, an event hub trigger. I'm not like. Do you know what this means? I'm not really familiar with that. I just always use.
I think that just means that it's like within the function app itself, it needs to be executed from within the function app, I believe, right? So basically, the runtime can see this public method and kind of see like, here's the name of the function, here's the things that will trigger and stuff like that.
Right. Yeah. Like this is This is like the main method of like a Java program. Like this is what's going to run when something's triggered. So, really quickly, I'm just going to go into like some of this code in C# about like the validation and the result, like what we do with the validation result. And we'll look at validate. So, like we parse that string, that's the JSON string, into one of these args objects, and then we can grab like the name and the age. But I think what's really key to know here is when we don't have name and age, these guys can be null, right? And that's like this null is the source of like a lot of bugs in software, as I'm sure you guys are familiar with. So like in this if statement, right, we check for null, like maybe name doesn't equal null, and since this is like a nullable int, if it has a value, then it will return like the name and age, like a name and age object with, those two things that we know there's a value there. And yeah, like the same thing, like only name, if we get only a name, we'll get back like an only name validation result. Only age, same thing. And then if it's neither of these, we get back a name or age. Not very interesting. And then from there, right, we can say, like, just make that result, like, get the string and make the result from it. Again, not very interesting, but that's basically like a very simple implementation of one of these guys. Go back here. So, that being said, we're going to talk a little bit about functional programming with F# and why, and the concept using them in functions is, we believe, is preferred over like that C# implementation we saw. So some of the advantages of using F# is there's a lot less noise and the code is more concise. You don't have to like write classes for everything. You just have functions, right? You don't have that boilerplate code with curly braces and semicolons. It's just functions, which we'll see in a moment. You get type inference as well, which is interesting. We'll go over that. You don't have to like declare your types like you would in Java, which I'm sure you guys all know. And like in general, just it takes a lot less code to solve the same problems. F# also is a very powerful type system, meaning that it's very hard or almost impossible really to mix up your types, which like I think you guys will see as well. Actually, if you do it well and make your types well, then it's impossible to get to invalid states and dealing with null too, which is I think pretty interesting. And just like there's a lesser brain to code gap, like just getting something up and running, functional programming allows you to think differently than you would in terms of object-oriented programming. In terms of this, which I think we'll see the big advantage, you can see, you very clearly see that your data is moving through like a pipeline of transformations instead of like making objects and mutating state. So let's jump right into the F# code, which is the same implementation as this C# code. Again, like very similar, right? You have your function name, you have run, which is an HTTP trigger, takes a request message and that logger. But I think this is very interesting because, again, like I said before, you can clearly see like a pipeline of transformation, right? There's this operator in F# called like this operator here, this forward pipe, right? Which takes the value from this guy and it will just pipe it into the function. Does that make sense? Like, so request.content read a string result returns like that string that we saw on the C# function, right? But instead of, saving that off into a variable and doing like the deserialize, we can just pipe it right into parse. And again, we can from that pipe into, then validate that, and then from that validation, make a message, then make an HTTP response. Does anyone have any like questions about pipe ahead, or does that make sense? Cool. So let's go through validate request. So we see that like the validate request takes in the args, which actually right here you do have to declare your type, so maybe I lied a little bit, but in the other functions you don't have to declare your types. Here though, again, like I'll bring the C# code up actually just so we can get a comparison with this method. So again, right, we can say maybe name, which is what we did here. But the interesting thing about this is maybe name is, it's not going to come up for me. Oh man. Well, this try get property returns what's called an option. And what's really interesting about option is it's compile time checked, so you don't really ever have to check for null, right? Like in this example here, we had to say like not equals null. But when we try to get the property name, if it's not there, we get a strongly typed null, or I'm sorry, strongly typed none. Or we get a sum with the thing wrapped inside of it. And I think you'll see what I mean in a minute when we look at this, but that's pretty nice, right? Like you don't have to worry about null here. Like that's a big advantage. Does that make sense? Like you don't like that. That's I think like a very big win in F# compared to the C# implementation of it. Then this is called a pattern match, which is basically like, which is more powerful than these ifs because you can actually pattern match on the types, right? So again, like this is the sum that I was talking about, and the sum has the JSON string wrapped inside of it. So we're saying like, okay, this is the case where maybe name and maybe age, we do have something. We have a sum that has the JSON value string, and maybe age has the JSON value age wrapped inside of it. We can pull those values out and we can get the name and age. We can return that validation result. And this is the case where we only have the name, but we don't have the age. It's none. It's not null, it's none. And it's nice because, like I said before, it's compile time checked where, it's compile time checked where you don't have to worry about like something being there or something not being there. So now we can only do, only name And this is the case, again, not very interesting. We can say there's no name, but we do have the age. We can return an only age. And then this is the case where like we don't have any of them and return no name or age. Does that make sense? Or like, do you guys have any questions about that? Cool. So let's go back to this guy. So now we see that like we validated a request, and now we're piping that validation result that we looked at in this function here. We're just going to pipe it right into the next one. Or when we look at the C# code inside of inside of here, we just take that validation result, and right from that validation result, we just have the string of the message. But in the C# code, or I'm sorry, in the F# code, we're going to take the actual result and then match the type we gave and make the string from that. So here, since we piped in that validation result, we can see from up here that when we return like name and age, we're going to match that down here in this function and return the string. So when we match the name and age case, we're just going to make a string, and printf is just like a way to interpolate values into a string. We'll say name and age, and we'll return the string like, hello, some name, you are blank years old. We have the only name case where when we matched up here, we'll return the string like, you didn't tell me how old you are, but I know your name is whatever. If we have only age, we'll return like a string appropriate to that, and we have no name or age, we'll return a string appropriate to that. Then from there, we just make a HTTP response that has that string and returns a response. So I think we are going to actually run this and see what it looks like. I've already compiled this, so like what I showed before about making functions, you can run it by just going into like where you outputted the result of a build and say funchost start using the Azure Functions CLI. We'll spin up a function, and we'll use something like Postman, which is just a way to send HTTP requests. And I already set this up as well. We have a body here with the name and, my name's Nick and I'm age 24. So if we send this guy, we get the result like, hello Nick, you're 24 years old. If we come back up here and we'll take out age, for example, and just have the name and send it, and we'll come back and say, you didn't tell me how old you are, but I know your name is Nick. No, and we can keep playing this game. Whoops, take out the name here.
It's a really huge win that you can run this locally. I mean, it sounds trivial, but early on, some of the serverless things, you couldn't run it locally, or it was very difficult to do so, right? So you had to actually push it up to the cloud before you could test it. So you'd have like a test instance you'd be running up there and things like that. So they've done a lot to make it a lot more seamless. It's nice to be able to actually run the platform locally before you send it on up.
Yeah. Oh yeah, it's really big. It's really nice to run them in isolation too from each other. It makes it a lot easier to test. Cool.
That's it. Thanks for your time.
Thanks, guys.